Hola clase. Today we are going to learn to work with irrational equations, and as usual I will give you a step-by-step how-to guide and then we'll make an example together. Now, irrational equations are those with the variable inside a surd, and remember that a surd is nothing else than a fractional exponent. Most of the times, like 95% of the times, is going to be a square root, which remember is a default, but it can be any surd, any fractional exponent. They all get solved the same. Now how to step by step. First of all, you're going to have to rearrange to leave that surd alone. Doesn't matter which one it is, but you want it as subject. Then you're going to want to get rid of it. So for that, you will going to need to make an exponent. In the 95% of the cases where this is going to be a square root, the way of eliminating that is going to be a square, which would cancel it, but it could be any exponent. After that, you're going to solve it, and then, and this is important, at the end, you need to check the solutions back in the original equation, because not all of them may be valid. That's something that we haven't had before, but now it will be vital. Now let's see that in an example. They ask me to solve this equation, which happens to be irrational because the first side it's within a surd. First I need to check to isolate the surd. In this case it's already alone, so I don't have to rearrange anything. I can go straight to thinking about eliminating it. Now, this case I'm going to have to square because that will cancel the square root. In the other side, I'm going to have to expand. Instead of going through your crab claw, that some of you call it, or trying to do a punnet or anything like that, remember that you've got your tool about Pascal's triangle, which allows you to expand monomials. So if it's a square, it's the square of the first plus or minus 2 times the first times the second plus square of the second. And once you know it, you can use it every time. So in this side, well, this cancels, so this just leaves alone whatever was inside the surd. In the other side, x squared, square of the first, minus 2 times the first times the second, so that's going to be a 4x, plus the second square, that's a 4. Now this is a quadratic, so I can rearrange, leave it all in one side, so it's ready to solve. I'm leaving it in the left side because it's where we're most used to see it. X squared, and then I'm going to have like terms in the x, unlike terms in the independent coefficients. So minus 4x minus 2x is going to be a minus 6x, plus 4 plus 1 is going to be plus 5. And then I can solve in any method I want. I can use my quadratic equation, I can factorize. This case is quite easy to factorize. 2x is here because remember, in this case a equals 1. And then two numbers that multiply to 5 and add to minus 6, that's going to be minus 5 times minus 1. And from there I can solve x equals 1 or 5. Now this could be a quadratic, I could be done, but it's not, it's an irrational, so I need to come and check in the original. The original is the square root of 2x minus 1 equals x minus 2. And I need to evaluate it for x equals 1 and for x equals 5. Well, for x equals 1, well, 2 minus 1 square root of it, is that going to be the same as 1 minus 2? Well, if you do the first side, that's going to give you square root of 1, which is 1. 1 minus 2 is minus 1. Well, they're definitely not the same. So this is not a valid solution. You will not be able to put it there and make this true. We go on to seconds, and more of the same. We evaluate, and we can do this in our brains with practice. I'm just putting it here so we know what we're doing. Well, in this case, that could give me square root of 9, which happens to be 3. So yes, this is a valid solution. This is the one that we will use. So we come in here, let's go here in this side, and we give the only solution that actually works. We box it, and we're done. Okay, now it's your turn to go and practice. Thanks for watching.